Hi students, now we are going to consider Taylor series method, which is one of the numerical methods to obtain a series solution of a given first order and first degree ordinary differential equation. So what is the method? To know the method first, let us consider an ordinary differential equation of first order and first degree, which can also be called as an initial value problem. Why initial value problem is? Observe this example. This is a general form of writing a ordinary differential equation. dy by dx is equals to f of xy with the initial condition y of x naught is equals to y naught. So whenever we have the initial condition to be mentioned with the problem, we call such type of differential equation as an initial value problem. So we will be given a problem of this example or this general example kind. We are going to now consider the Taylor series expansion. So what is the Taylor series expansion? Which gives us the value of y at the point x which satisfies this equation is given by the expression y of x is equals to y of x naught plus x minus of x naught by 1 factorial into y dash of x naught plus x minus of x naught whole squared by 2 factorial into y double dash of x naught plus x minus of x naught whole cube divided by 3 factorial into y triple dash of x naught plus etc. So you can write the number of terms based on the requirement in every problem. So we are going to now observe the RHS. We are going to consider those values from the given problem, substitute into the RHS of this Taylor series expansion, simplify using the calculator. We arrive at the approximated value of y at some given point of x for a ordinary differential equation of first order and first degree. Now when you observe the RHS here, I have y of x naught. What is y of x naught? Y of x naught is nothing but the initial condition of y at the point x naught, which we can also write it as y naught. Okay, so this value will be substituted into the RHS first term. Now when I observe the second term, I need to find y dash of x naught, y double dash, y triple dash plus etc. values. So which can be obtained by considering the successive differentiation of the given expression. So we are going to consider the given expression, which is dy by dx is equals to an expression in terms of xy, which are generally mentioned as f of xy. Then we are going to substitute x as x naught, y as y naught, the initial values, and simplify. We are going to get the required values of the derivative terms at the initial conditions, which will be substituted into the series expansion. Then simplify. We are going to arrive at the approximate solution of the given ordinary differential equation at some point x. So now let us consider the problems on Taylor series. So the problems are of this kind. Employ Taylor series method to solve dy by dx is equals to xy minus 1 with y of 1 is equals to 2 at x is equals to 1.02. Now what are we going to do first? First is consider the given expression. They have mentioned dy by dx as xy minus 1. I can also write it as y dash. Then what is y naught for the given problem? Y naught is 2 and x naught is 1. We have to find the value of y at some point x is equals to 1.02. So first is we are going to write the Taylor series expansion for the given problem. So this is our Taylor series expansion. Now we will find the required terms to be substituted into the RHS of the expansion. So what we do? We are going to consider the Taylor series expansion as equation 1. Then consider the given differential equation. It is y dash is equals to xy minus 1. Now into this substitute x by x naught, y by y naught. So when I substitute here, x naught value is 1 from the given problem and y naught value is 2. So when I substitute and simplify, I am getting y dash of x naught, in other sense y naught dash, as 1. So which should be substituted into the expression. Then I have to find y double dash, which is equals to x into y dash plus y. So what is y double dash? How we got this expression? I have the previous expression for first order derivative. Differentiate this again with respect to x. When I observe the first term, I have to use the product rule for differentiation. So by the product rule, it is x into derivative of y is y dash plus y into derivative of x is 1 minus derivative of 1 is 0. So when I substitute, I am going to get y double dash of x naught. So what is y double dash of x naught then? Replace x by x naught value, y by y naught value, and similarly y dash by y naught dash value from the previous step, which gives us the value to be 3. Now similarly find the third order derivative. Again, to apply the third order derivative or to find the value of third order derivative, I am going to differentiate the RHS. So when I differentiate the RHS, I am going to get the expression as x into y double dash plus y dash into derivative of x is 1 plus derivative of y gives me y dash. When I simplify the expression, I can write this as x into y double dash plus 2 into y dash. Now we are going to substitute x naught and y naught into the required expression. So it gives us x naught into y naught double dash plus 2 into y naught dash, and substitute the respective values. X naught is 1, y naught double dash is from the previous step, so it is 3 plus 2 into y naught dash is the first value what we have obtained. I am going to substitute, and if I simplify, I get the value as 5. So once we have obtained all the values, now I am going to consider equation 1, and then we are going to substitute for all the requirements in the equation 1. So what is x? X is 1.02 and x of y naught is this expression. I have substituted for x and x naught here. Fine. Now simplify using your calculator. We are going to get the value as y of 1.2 is 2.02061. So this is an approximate value, not the exact solution of the problem. Now let us see the next problem. So the next problem is employing Taylor's series method, find the approximate solution of dy by dx is equals to 2y plus 3 into e to the power x with y of 0 is equals to 0 at the point x is equals to 0.1 and x is equals to 0.2. So observe here, previous case it was only we have to find the value of y only at one point. Here they have asked us to find the value of y which satisfies the equation at 2 points. So what we do, time being, we are not going to substitute for x in the Taylor series. We are going to keep it as it is. Later we are going to substitute and simplify. So consider the given expression. It is dy by dx is equals to y dash, which is equals to 2y plus 3e power x with the initial value. So this is our x naught and the corresponding value of y is 0 for this case. So I am going to write it as 0. Then also x they have given as 0.1 and 0.2. What is the next step now? We are going to write the Taylor series expansion. So what is the Taylor series expansion? I have the Taylor series expansion as y of x is equals to y of x naught plus x minus x naught by 1 factorial, y dash of x naught plus x minus of x naught whole squared by 2 factorial into y double dash of x naught plus x minus of x naught whole cube divided by 3 factorial into y triple dash of x naught plus etc. Now into this we need to substitute for the RHS. So call this expression as equation 1. Now consider the given equation, which is the definition for y dash. It is y dash is equals to 2y plus 3e to the power x. Substitute here the values of x naught and y naught, which gives us the expression for y dash of x naught. So what is y dash of x naught? It is 2 into y naught plus 3 into e to the power x naught. So 2 into y naught value is 0 plus 3 into e to the power 0. So 0 into any value is supposed to be 0. So I am going to get it as 0 plus 3 into e to the power 0 is 1. Hence the value of y dash of x naught is 3. Okay. Then Similarly, find the second order derivative. So I am going to differentiate the previous expression, which will be given as y double dash is equals to 2 into y dash plus 3 into e to the power x. Then if I simplify it, I am going to get it as y double dash of x naught is equals to y double dash of 0, because x naught is 0. So 2 into y naught dash it becomes, which is nothing but the value of y dash at the point x is equals to 0, plus 3 into e power x naught. So I have it as 2 into y naught dash is from the previous step, which is 3, plus 3 into e power 0 is 1. So finally I am going to get it as 2 into 3 is 6, 6 plus 3 is 9. Similarly, we will find the next derivative, which is the third order derivative. So what is third order derivative of y double dash? It is 2 into y double dash plus 3 into e power x. 2 into derivative of y dash gives me y double dash. So we are going to substitute x as x naught, y as y naught into this corresponding expression, which gives us the value of y triple dash at the initial condition. So when I substitute, the expression becomes 2 into y naught double dash plus 3 into e to the power x naught, which is equals to 2 into y naught double dash is 9 from the previous expression, plus 3 into e power of 0. So which gives us 21 as the value. Now after obtaining the values of all the derivatives at the initial conditions, we are going to consider equation 1 and substitute. So I am going to consider the equation 1. We are substituting for x naught and x values first. Fine. And then we are going to substitute the required value. Y of 0, which is y naught, is 0 from the given statement. X it becomes, because x naught is 0, into y dash of x naught is 3, which is the required value, plus x squared by 2 into 9 plus x cubed by 6 into 21. Then simplify as usual. We arrive at equation 2. Why we have kept as it is here? This is because we have to find the values of y at two different points of x. So let us call this as equation 2 now. Fine. So this is also called as series solution or expression in x for the given problem. Now what I'll do, I'll take up the two different cases. What is the first case now? First case is substitute x is equals to 0.1 into the equation 2, because I need the value of y when x is equals to 0.1. So when I substitute and use my calculator and simplify, because it is general addition and simplification, I am going to get the expression value as y of 0.1 is approximately equal to 0.3485. Similarly, if we substitute x as 0.2 into the equation 2, we get the expressional value as 0.808. Observe here, these two values are only approximate values but not exact solution of this differential equation. Got it? So this is how we are going to solve Taylor series method problems using the Taylor series method.